Okay, so Leetcode practice time. So there are two goals. The first one is to see how to solve this problem, and the other one is to see how you're going to behave during your interview. So let's get started. So remember, the first thing is always to try to understand the problem, and then if there's anything unclear, please bring up the question, and also think about some edge cases at the very beginning. So let's take a look. So lowest common ancestor of a binary tree. So given a binary tree, find the lowest common ancestor of two given nodes in the tree. So according to the definition of the Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendant, where we allow a node to be a descendant of itself. Okay, so let's take a look at this example. In this tree, 5 and 1 common lowest LCA is 3, and for this one, 5 and 4 LCA is 5. Alright, so it seems to be pretty clear. Let's think about some edge cases. So what if there are two nodes, P and the P node, maybe the P or Q doesn't exist in the root. So it seems like this one has already answered our question. P and Q will exist in the tree. And P, okay, so P, Q, okay, all node dot value are unique. Okay. And P is not equal to Q, alright? So, okay, if P is equal to Q, then pretty much you just need to return itself, but it's not equal. So the number of the nodes in the tree is in the range of 2 to the power 2, and then 100,000, okay? Yeah, so it seems to be, okay, so after we understand the problem, I think there isn't too much of the edge case we can think about. It says that tree is not empty, and P and Q are not equal, and also P and Q for sure exists in the tree. So if it exists in the tree for sure, then it should have a we are not going to return an endpointer, because for sure we are going to have a lowest common ancestor for it. Alright, so after you understand the problem, the next thing is about finding the solution. So will be the solution for it. This seems to be we could use some recursion to solve this problem. So okay. So if this one is implemented using recursion, let's see how to define it. Yeah, so I think what we could do is like this. So we are going to visit its left subtree and the right subtree, and the return value is defined if we find either node P or Q in the from this root. We are going to just return okay, so first of all, we are going to try to search the left subtree and right subtree. So if both left subtree and right subtree return non-empty, then it means some of the like P and Q exist in the left subtree, and the rest P exists in left subtree and Q exists in subtree, or vice versa. So that's the lowest common ancestor we are trying to find. So if for some reason we already encountered so the exit of this recursive function. So if we encounter the P or Q, then we are going to return it. And if the left subtree return a non-pointer, doesn't return a pointer that points to some node, then it means it is the it could contain either P or Q. Then we just return the left subtree. The left subtree, the root of the left, what is returned from the left subtree call, and and similar for the right thing, for the right right subtree. And if both, if we call this function on both left and subtree and return non-empty, then we are going to return the root of it. Okay, I think it seems to be fine. So I think it seems to be fine. And the runtime is going to be all of n because we are going to visit every node within the tree. So let's do some coding work on top of it. So for coding part, correctness and the readability and also the speed, all are what we care about. So let's see. This one, lowest common ancestor. If I would say if root is equal to a non-pointer, then we definitely need to return a non-pointer, and that's the one exit. If p root is equal to p, then we just return the p. And if root, alright, so if root is equal to p or q, root is equal to q, then we just return the root. So that's the exit of it, of this recursion. And the other thing is if root is equal to p or q, then we simply return the root. And if okay, so I think the next thing is to call the recursion. So node left node is equal to lowest common ancestor on top of root dot left on p and q, and we are going to call it on the right thing, right node, root dot left dot right. Okay, so if both left node is not equal to none and right node is not equal to none, that's the place, and that's the time we find the lowest common ancestor. We are just going to return the root. Yeah, so, and if left node is not equal to none, then we just return the left node. Otherwise it is like it's like, so if both of them don't return, okay, so this one we are going to return left node is equal to none, is it? If yes, then we are going to return the right node. Otherwise we return the left node. Yeah, so I think, yeah, so if both are none, then we are going to just return none for it. Yes, I think that's pretty much it. Let's take a look at that. Take a look at the example 2. Let's see for this one. So first of all, we are going to see, we start from this node, and first we dive into this left node, and in the left node we dive into this one. So it is not equal to 4 or 5, and so it's a leaf node, so both the left subtree and right subtree are going to return none. So this is going to return none for left and right node, and similarly we are going to return none from the left subtree. And for here, similarly, when we call 7, this one is going to return none. This one is going to return the Q node. So we are from here we are going to return the Q node from here. and then when it is equal to 5, and then after left node and the right node are returned, so after we call the right node, it returns the 4, and this one, because root is equal to p, so we are going to return this root. And then here we are going to return none. So this one is going to, and when it comes here, we return the left node, which is this one. So we are going to return 5, which is true in our case. Yeah. So let's see other things. So let's see this one. So for 1 and 5. So when we call this, it is going to return P, and this is going to return Q, and then here, because left subtree and right subtree both are not none, so we are going to return this root node. I think it looks pretty good. Let's give it a shot. Okay, so accepted. Okay, so everything looks good. So I would say, yeah, so I forgot the last thing. So the last thing is about testing. So the testing is, what I did is going through our example, explain how this piece of code is going to work, do some sanity check, and at the end set up some test cases to increase the test coverage. So I would say definitely set up example 1 and example 2. The first thing is that P and Q exists in different branches, both exist in left and right subtree. So we are going to use a root. The other one is both left and right exist in one branch. So we are going the node P is a parent of Q. So that one we are going to just return P for it. Yeah, so that's it for this coding question. If you have any question about this solution or this coding puzzle, please leave some comments. And if you find this video a bit helpful, please give me a thumb up. Please subscribe to this channel as well. I'll see you next time. Thanks for watching.